We're given ages 30 and 40. Future lifetimes are independent. The deaths of 30 and 40 are uniformly distributed over each year of age. So that's UDD. Probability of dying the next year at age 30 is 0.4. Probability of dying the next year at age 40 is 0.6. And we want to calculate this. So we're going to have to use a formula for this. And so that's going to be an integral from 0 to 0.25. And that would be TP 30.5 times mu of 30.5 plus t times TQ 40.5. So the formula that I'm using is, so let's say I have this. So integrating from 0 to t, tpx mu x plus t, tqy dt. All right. So I do have UDD here. Okay, so if I'm looking at TP 30.5, that's the same thing as the complement of this, which I can write as 1 minus TQ30 over 1 minus 0.5 Q30. And I can combine these into one fraction and have 1 minus a quantity 0.5 plus t times Q30 over 1 minus 0.5 times Q30. Mu of 30.5 plus t, we're going to break this up into 30 plus 0.5 plus t, which is Q30 over 1 minus 0.5 plus t times Q30. And then finally, TQ 40.5 is TQ of 40 over 1 minus 0.5 Q40. Okay, now we're going to put it all together. So I have the integral from 0 to 0.25. We have TP of 30.5, which we said is 1 minus the quantity 0.5 plus t times Q30 over 1 minus 0.5 times Q30. The next thing was the mu of 30.5 plus t, which we said is Q30 over 1 minus 0.5 plus t times Q30. And then lastly is the TQ 40.5, which is t times Q40 over 1 minus 0.5 times Q40 dt. Okay, so now I'm going to cancel out these two, and I'm just going to plug in what was given. Q30 we said was 0.4, and then Q40 is 0.6. So we have 1 minus 0.5 Q30, and then I'm going to multiply that by 1 minus 0.5 Q40, which Q40 is 0.6. So when we clean that up, what's left in the integral is 0.24 over 0.56 t dt. So when we integrate that from 0 to 0.25, we end up getting, let's see, 0.0134 as a final answer.